Okay, in this video we're going to look at factoring perfect square trinomials and difference of squares. Okay, these are also known as sort of special products here. Now, before we actually get into what is a perfect square trinomial or what is a difference of two squares here, let's review sort of the special products with the full method. Okay, so let's start over here with 2x minus 3 quantity squared. So recall there's a shortcut we can do here to expand this. And you probably noticed that factoring is sort of the reverse idea of this. So let's actually go forward with this first, and then we can go in reverse to factor. Now, recall we have a shortcut for 2x minus 3 quantity squared. We have square, square, twice the product. So I can take 2x and square it, and that would be 4x squared. Negative 3 squared would be positive 9. So there we have square and square. Now, twice the product means I'm going to actually take these two and multiply. 2x times negative 3 would be negative 6x, and twice that would be negative 12x. Okay? Now, what we're actually looking at there, I don't really need those parentheses. This is called a perfect square trinomial. Okay, and what we're going to actually do is look at the process of starting with this and going backwards to that. Now, the most important thing about factoring a perfect square trinomial is not really the factoring, it's the identification of the perfect square trinomial. Because when you look at it, it really just looks like, if you'll kind of glance back at your worksheets here, it really looks like a problem from set 4. And I could actually work this problem out like it was a problem from set 4, a trinomial with a leading coefficient. But when I get larger numbers here, it's going to be beneficial to actually recognize that this is a perfect square trinomial. So let's focus on the recognition of it. And so there are 3 things here that you're going to have to sort of recognize about a perfect square trinomial that makes it a perfect square trinomial. The first thing here, I'm going to make you a little bullet list, is that the first and last terms, okay, which is the 4x squared here and the 9 in this case, the first and last terms are perfect squares. Okay, that's usually the telltale signs to them because that's usually the easiest one to recognize. Now, this one's a little subtle, but it's still easy to do. Okay, the second thing is the constant, which in this case is my 9, must be positive. Okay, if my constant is not positive, then it absolutely cannot be a perfect square trinomial. Now, the last thing is sort of the harder thing to recognize here. Okay, so just follow along the best you can here. So I'm going to look at this 4x squared minus 12x plus 9, and we'll look at it as 3 terms. You have the first term, the second term, the third term. The square root of the first term times the square root of the third term, or we could say the last term, okay? The square root of the first term times the square root of the third term times 2 should be equal to the second term, or the middle term. Okay? Now that's by far the hardest thing to sort of recognize. So let me rewrite this perfect square trinomial and model this for you. Okay, this is something that you're not going to get right off here. So just be patient here if you didn't really understand all that. Okay, so this is supposedly a perfect square trinomial. Let's go through the list and we'll spend a lot of time here talking about that third bullet. So first thing on my list, first and last terms have to be perfect squares. So 4x squared, yep, perfect square. 9, yep, perfect square. Okay, the next thing, I'm going to check this off my list here. Alright, constant must be positive. Alright, remember the constant is the one that doesn't have a variable, so in this case the constant is 9, and the 9, sure enough, that 9 is positive. So my constant is positive. Now, for the third thing, this requires like a little bit of scratch work, so to speak. You take the square root of the first term times the square root of the third term. So the way I do this, when I see my perfect squares right there, I write, kind of light or kind of small, I'm going to write the square root above the 4x squared. So the square root of 4x squared would be 2x. Now, the same thing with the third term. The square root of 9 would be 3. Okay? Now, if I take these numbers and I multiply the 2x times the 3 and double it, so I got to say times 2, I would get the 12. So notice 2x times 3 would be 6x, and 6x doubled would be 12x. Now, you can disregard the negative sign. You don't really have to worry about that being negative 12. Okay, so when we say the second term, you don't really have to pay attention to the sign right there. Now, that's how you tell if something is a perfect square trinomial. Now, the actual factoring is very, very easy. Okay, to actually get the factors here, once you recognize this a perfect square trinomial, the factors are going to be these two numbers that you identified earlier, 2x and 3. Okay, so I'm going to do 2x and a 3. Now notice I haven't said anything about signs. The sign that goes in between them will be whatever this first sign is right here. So it will be minus, and this would be a quantity squared. And you notice that's what we started off with. 2x minus 3 quantity squared. Okay, let me squeeze one more down here, and then we'll start looking at factoring some differences of squares here. So let's look at one more that's a perfect square trinomial. Let's try this one. Let's do 25x squared. Let me think of a nice one here. Let's say plus 70x plus 49. I think this is one here. I might have to change it up to make it into one. Alright, so let's notice our checklist here. Alright, are the first and last terms perfect squares? Yes, sir, they are. Is the constant positive? Yes, sir, it is. Now, here's the tough part. The square root of the first term, I'm going to write a little bitty above it here, would be 5x. The square root of the third term would be 7. Now, if I take these two numbers and multiply and double, it should be the middle term. So 5x times 7 would be 35x, and 35x doubled, sure enough, is 70x. Okay, so it's the identifying part that's the hard part. So now, our factors here, we're going to write, this is going to factor into 5x and a 7. Recall you used the first sign, okay, which is a plus in this case. And then you just say it's a quantity squared. Okay, and notice how I can check this. You remember I have my pattern. I have square, square, twice the product. So square, square, I would get 25x squared and then 49. And then twice the product. 5x times 7 is 35x. 35x doubled is 70x. There, I've checked my work by doing square, square, twice the product. Okay, so that's all this is really doing, is undoing the square, square, twice the product idea, that shortcut. Now, let's go on the right side here, and now we're going to look at what we call differences of squares. Now, this is a review, so this is not an example of differences of squares. This is actually going backwards. Now, recall we have terms to describe what these are of each other right here. One is 3x plus 5, the other is 3x minus 5. So they are not exactly the same, but the signs that are between them are different. So recall here, those are called, remember, conjugates of each other. Okay? And when I do the full method with conjugates, recall what happens when you do first, outside, inside, last, is the outside and inside terms cancel. So all you have to do is just first and last. Okay, so if I multiply this here, I would get 9x squared for the first, and then 5 times negative 5 would be negative 25 for the last. Okay, now this, what we have here now, let me clean off some of this real quick. What we have in this case is a difference of squares. Okay, so let's make a little list just like we did with the other. Now notice how a difference of squares and perfect square trinomials both involve perfect squares, but they are definitely different looking. Notice in this case that a difference of squares is a binomial. Okay, it's not a trinomial. It doesn't have 3 terms. It only has 2 terms. Okay, the other thing, here's the biggest thing. It must be a difference. It cannot be a sum. In other words, this sign that's in between them must be negative or it will not factor. Okay? So that's the thing that we have to look at to identify perfect square trinomials. Now the other thing I'm not mentioning that's probably the obvious thing is they must be perfect squares. Both of them. Okay? Now, here comes the big statement. Okay? Let me write you a little statement here. Okay? A difference of 2 squares. Okay, so these are both numbers that are perfect squares that are being subtracted. Is the product of 2 conjugates. I'm pretty sure that I don't spell conjugates correctly, but I think that's actually conjugates, but I suck at spelling. Now, it is the product of 2 conjugates. Now, the way that we get those 2 conjugates is actually really simple. If you look at it, you can probably tell. It's just the square root of this number and the square root of this number. So that would be 3x and 5. So we'll have 3x and 5 and 3x and 5. And recall, conjugates have different signs. So one is plus, one is minus. And it does not matter which one is plus is minus. Alright, so I'm going to just call this one plus and this one minus. Surely the order there does not matter, so I could have reversed that. Okay, to me, differences of squares are the easiest things to factor. Now, let's look at some examples here of differences of squares. Okay, so I want you to notice in each one of these, they have minus signs. Okay, so they are differences. And notice every single one of them here are squares. Okay, so think, what's the square root of this term? What's the square root of this term? The square root of x squared is x. The square root of 36 is 6. So it will be the product of 2 conjugates, x and 6 and x and 6. Okay, now remember, conjugates have to have different signs. So one is plus, one is minus. And there again, it doesn't matter which one is plus and which one is minus because the order doesn't matter. Let's look at the next one. Okay, you've probably figured out this pattern by now. Alright, so let's look. Difference of squares. 4x squared is perfect square, 25 is perfect square. It's a difference. So now, my square roots here would be 2x and 5. So now we're going to have 2 conjugates with 2x and 5. So one is plus, one is minus. I'm going to actually do it this way. I'm going to say minus on this one, plus on this one, just to show you that the order that you put the minus or the plus doesn't matter. Now, let's do one more here, and then we're going to look at identifying all these. 9x squared minus 100. The square root here would be 3x. The square root here would be 10. So we'll have 3x and 10, and 3x and 10. One is plus, one is minus. And notice, if we did first and last on all these, we would just get these back, because that's how we multiply out conjugates. So that's how you factor a difference of squares. Now, with these special products, It's more about identification than it is factoring. I actually already did this part. I wish I'd have done that earlier. Okay, this is perfect square trinomials again. We've already kind of bulleted that list. Now, let's take a look at just a couple more here. We've actually already done this one. Let's look at this one. Okay, now look at the difference. I have perfect squares here and here. The fact that the middle one's a perfect square doesn't really mean anything. But this is a perfect square trinomial because it's a trinomial. It's got 3. It's not a binomial, so it's not a difference of squares. So recall on these, we take the square roots here and here, so that would be 2x and 9. Now the other thing is the constant has to be positive, which it is. And now the square root of the first term times the square root of the last term doubled must be the middle term. So 2x times 9 would be 18x, and 18x doubled is 36x. So now when we factor this one, now remember this is not the product of two conjugates. We're going to say 2x and 9, and it's a quantity squared. It's not conjugates. And we use the first sign there. Okay, now let's actually look at some examples like the ones that you're going to have to work. So I've patterned these examples after the set that you're going to have to work here with differences of squares in perfect square trinomials. So the directions are going to read just like this. Circle each perfect square trinomial, underline each difference of squares, and factor. Okay, so what's going to happen is some of these aren't going to be differences of squares and some of them aren't going to be perfect square trinomials. Again, one of the main things about this topic is the identification, not so much the factoring. Now let's look at the first one. We have x squared minus 9. Now that is definitely not a perfect square trinomial because it's only 2 terms. So let's see if it's a difference of squares. Okay, well, is this a square? Yes. Or is this a square? Yes. Is it a difference? Yes. So it is a difference of squares. Now recall, let's actually factor it. Oh, let's see what we're supposed to do. We're supposed to underline it. Okay. That's a difference of squares. Now let's factor it. So remember, the difference of squares is the product of two conjugates. So this would be x plus 3 times x minus 3. My x and 3 here are coming from the square roots of x squared and the square root of 9. Okay, now let's look at the next one. X squared plus 9. Definitely not a trinomial. Now let's see if this is a difference of squares. Okay, well, is this a square? Yeah, that's a square. Is this a square? Yeah, that's a square. Is it a difference though? No, sir, it is not a difference. That is a sum. So this is not a difference of squares, therefore you cannot factor it. So I'm not going to do anything to that. I'm not going to circle it. I'm not going to underline it. I'm not going to factor it because the truth is that I can't. Okay, let's go to the next one. So on this one, what you guys can do here if you want to, if it's not a perfect square trinomial or a difference of squares, you can just cross that problem out and you don't even have to work it. Okay, again, it's about identification more so than the factoring. Alright, the next one, 4x squared minus 9. Now that's a binomial. That's a perfect square. That's a perfect square. And that's a difference. So now let's factor. The square root of this one and the square root of this one would be 2x and 3. Now, a lot of people get confused right here. Do they think, okay, do I put 2x minus 3 quantity squared, or do I do the product of two conjugates? All right, you remember a difference of squares is the product of two conjugates. It's not a quantity squared like a perfect square trinomial. This is why I do this video with both of these, because a lot of times my students will confuse these. So the one will be plus, one will be minus. Okay, let's look at the next 3. Now, you should probably notice that the next 3, nope, wait a minute, I was supposed to underline that one. Okay, so because it was a difference of squares. Now, it says circle each perfect square trinomial. Now, all of these 3 are trinomials. So let's try to identify here which ones are the perfect square trinomials. Okay, so let's notice, and let's maybe go back to our list just a minute. I know this video is getting kind of long on me here, but just go with me. Okay, look at our list. Okay, the first First and last terms have to be perfect squares. The constant has to be positive. And you remember this complicated thing, the square root of the first times the square root of the third times 2 has to be the same as the middle term, or the second term. Alright, so let's go through that kind of slow here with these problems. Alright, so perfect square. Okay, now look at the last thing though. This says minus. And we said earlier that the constant has to be positive. And so since this 9 is not positive, it's really not a perfect square. Okay? So that is not a perfect square trinomial. It's not a difference of squares because a difference of squares can only be a binomial. See, a difference of squares only has 2 terms. Perfect square trinomial has 3. Now, let's try the next one. Okay, so here we go. Perfect square. And now it's nice and positive. Alright, so it seems to be working out. Now, let's check that middle term thing. So, I'm going to take the square root of the first term and write it above here, which would be 2x. And the square root of this term, which would be 3. And now, if I take these two and multiply and double, I should get the middle. So, 2x times 3 is 6x, but 6x doubled would be 12x. So, everything worked out until the middle term. The middle term is not working out there, so that is not a perfect square trinomial. What we should have had in the middle right there, you probably could have told, 2x times 3 would be 6x, and 6x doubled would be 12x. So we needed a 12x in the middle to make that a perfect square trinomial, so that wasn't one. Now, you notice the last one does. And recall, this sign really doesn't matter that that's negative. Okay, it's this one right here that matters. That has to be positive. So notice perfect square, positive constant. Now 2x times 3 is 6x, and 6x doubled is 12x. So I'm going to circle that one because that's a perfect square. Now recall how to factor these. 2x and 3 is going to be the factor. Now it's not like the one above. See, the one above here, this was a difference of squares, so it was the product of two conjugates. So this is not the product of two conjugates. This is 2x plus or minus 3 quantity squared. Now, recall the sign here. You just use whatever the first sign is right there. You just bring that down, and that's the sign that you use. So, for instance, if this problem would have been this way, notice I'm using the same numbers, but now this is plus right here. Then this would have factored to 2x plus 3 quantity squared. Okay, and be sure that you follow the directions closely on here. And again, the main thing is to work on identifying them first and then factoring.